So can you open up your Maya scene to last week's file? And we just want to go to the side view and just pan to an empty area. Alright, so pan to an empty area and then create a leg joint, something like that. Alright, so 1, 2, 3, 4 joints in total. So what we're gonna do this week is actually quite simple. There's only two main things that we want to achieve. One is called an IK handle and the other is called a controller. So let me just open up the final file and let you have a look at how it will look like. Okay, so this is what we are trying to achieve today. And you'll notice that when we create joints, right, our joints from last lesson can rotate our mesh, correct? So when you animate, you want to move the joints and not the mesh itself. But there's an issue, which is sometimes it's pretty hard for the animator to select the joints, okay, one by one. And if they accidentally move it, right, they can technically break your model, correct? And of course, to ask animators to animate vertex is even crazier. So we need to create controllers. And these controllers will control the bones. And the bones, in turn, will control the mesh. Alright, so it sounds very convoluted, like why can't you just do something direct? The reason being is that these controllers, number one, they're easy to select. Number two, they are basically controllers that you use to turn on and off things that you don't want the animators to touch. For example, this is a bit more advanced already, which we won't cover in our lesson. For example, right, like let's say the arm is not supposed to move, so we will actually take all the translate and we'll lock it and we'll hide it away. So when animators look at your rig, right, they technically won't see translate and you can hide away all these things. So they will only see what they are supposed to animate. Okay, so at the end of the day, the bones is for the programmer to use to set up the rig, but these controllers are what is really used by animators to control your model itself. Alright, and so we are also going to create something called an IK and FK handle. So our rig is being controlled from top down, right? Like for example, the shoulder controls the rest of the hand, the elbow controls the rest, right? The lower down hierarchy. And for legs, it's the same way. But if you want to do a walk cycle, right, to rotate your legs and then to slowly plant it is very difficult, okay? Just going by hip, leg, joint, it will go crazy. So we're going to create something called inverse kinematic, IK, whereby when you take the feet, right, let me just look for feet.
Whoa.
Yeah, okay. When you look at the feet, you just take the feet and you move and everything else will follow. In other words, right, normally we have to move the shoulder and then the hand will follow. And if you move the hand, right, nothing else goes on top. So inverse kinematic is you choosing where you want to place the hand and the rest of the body will follow. Okay, that's IK, inverse. Alright, so we are technically moving the feet and it will in turn tell the rest of the legs how to bend and how to move and so on and so forth. Okay, so your rig should look something like this. Okay, be able to move and rotate the feet at the same time. Okay, and lastly, at the end of the lesson, we're going to create a global control where we can move our entire rig, we can scale it up and down. You might think, no big deal, right? Just grab everything. Not true, okay? Not true. So I think that is about it. And of course, the root itself, you can rotate the top body, okay? You can spin, alright, you can, am I selecting the right, oh, I'm not selecting the right thing. Top body, alright, spin, and you can of course move it up and down. Alright, so when you want to do a character flying across, or you want his body to fall back, okay, this pelvis area or the root is quite important. Okay, so let's go to our file. And we're back at our feet. So first we have what we call FK, forward kinematic, right? If we want to move the feet, basically moving any bones would mean stretching it. So it's kind of destroying the structure itself. Alright, and so we can only rotate, correct? So let's go to our skeleton menu. If you can't find your skeleton menu, you must make sure you're in your rigging menu set. Am I recording? Yeah. Okay, so last week we talked about creating joints and everything up here. So this week we're going to deal with IK handle. Now, IK spline handle is for tail. Like if you want to create a tail or tentacle where it, it moves around like a snake, then you want to look at spline. So we're not going to touch this. We're just going to go for IK, which is right angle. Okay, it's sort of like bending. That's all. Okay, so in your settings, can you change your default? Okay, from rotate plane solver to single chain solver. Alright, rotate plane is slightly more complicated, meaning that you can customize how your knees bend. That means you can kind of rotate your knee facing angle. Yeah, but we don't want to talk about that yet. Okay, so single chain and press and just close the window. And what we want to do is to first select the hip, okay, the top, and then click on the heel. So the direction is very important, alright? So the hip first, and then the heel. So now, when you try to move it, it starts to react. Okay? And if you try and rotate, nothing will happen basically. Okay, now, so in your outliner, you should see two things that have been created. One is called the IK handle, and the other is called effector 1, which is hidden inside the joint hierarchy. Okay, we have the IK handle, we have effector 1. So IK handle is the thing that we use to move the whole leg. And it's a very small item. It's actually a crosshair or something like that. You look at this, it's just like one little green color crosshair. So it's very, very hard to select if you don't create controllers for your animator. Okay, so important thing, we need to name this. So you can call this leg underscore IK handle and leg underscore effector. Okay, and then next we want to create a so-called a handle or controller for your animator to move your stuff easily. So you want to move the IK and you want to rotate the joint, correct? So it's two different things, alright? Your IK itself, if you try to rotate, nothing much will happen in the z-axis, okay? You can't really rotate up or down. You can rotate sideways and then your knees will move, but that is about it. So very limited controls in rotation. So it's only meant for moving. So if you want to tap your feet, right, you're actually still moving the joint traditionally. Okay, you're clicking on the joint and you're rotating it. So these are the two functions that we want to create for our controller itself. So let's go to create here. And we want to look at something called a NURBS primitive. now if you look at the NURBS primitive window, right, the menu set, you notice that all the stuff looks very familiar, like sphere, cube, cylinder, which is the same as polygon, right? So what is the difference between the two? NURBS is calculated using mathematics. Meaning, right, if you are familiar with Photoshop's pen tool, you know how to use that? Yeah, click, 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 and then you kind of create a curve from clicking. Okay, and the curve is not you taking a brush drawing it, okay? It's more like you create points and it will generate an arc. So it's a mathematically calculated kind of graphic, which means that if you need to print a poster that is the size of a building, right? You need very sharp graphics, correct? So you can't possibly choose a resolution that's so big, or you can't possibly paint in such a huge canvas. So what people do is they create in vectors, which is the mathematics way, and then no matter how you scale, you resize it, right, it won't pixelate. Okay, vector art, if you are still unclear what I'm talking about, vector art looks something like this. It's very graphical, very clean. You can see all the lines. It's very different from painting, okay, because these are all like shapes, custom shapes that are done using a pen tool. And this kind can be scaled up really huge. You won't see the pixels, okay, everything is math. So if you were to create, let's say, a NURBS sphere, same thing, it will straight away look very smooth, okay, unlike a polysphere, right? It's really so little points, but it's super smooth. And if you right click on your NURBS sphere, you can see that the things look a bit different, like control vertex, isopalm, hole, surface point, and patch. So NURBS are meant for very smooth, rounded modeling, like car. If you are modeling sports car, right, Ferrari, or the very smooth hood and the what's that thingy, okay, all the mudguards. You want to use NURBS modeling, and nowadays actually, I think only product designers use it, because mostly in games or in animation we use a lot of polygon modeling. And if you were to put your models in game engine, right, it cannot accept NURBS. Alright, you need to convert to poly anyway. So that being said, you need to keep in mind that the controllers that we create, right, is not gonna go into Unity. Okay, so we will have to learn how to break down our animations into the bones much later on. So that's a next week kind of thing. So can you create a circle, okay, a NURBS circle, and just kind of place it around your leg itself. Okay, and you might want to give it a name, so I'm just going to call this leg controller, CTR. And I want to start the constraint. Constraint means that you're giving controllers the ability to control somebody else. That's constraint. Okay, so the controller can control selected channels of the bones. So let's say for IK, right, our IK handler is, we want to use the movement, right, the position of the IK. So let's select controller, the left leg controller, and then hold down shift or control shift and click on the IK. So again, the hierarchy is very important, alright? The controller constrains the IK. So controller first, then IK. Alright, and then we're going to go to our constraint menu up here. And we're going to use 3 different types of constraints throughout this whole lesson. In fact, right, what I'm covering right now is already like 95% of the whole class. So what we're going to do from here on is just a repetition of everything that is covered in this simple leg. Okay, so constraints, meaning that is controlling a portion of your object, alright? So we have orient constraint, we have point, and we have parent. Orient means that you are controlling the rotation, right? Orientation. Point is the position. Parent, if you look at the settings, right? Parent is a combination of both. You are controlling position and rotation at the same time. Alright, so with that in mind, I'm gonna constrain to point, right? So that I can adjust the movement. And you notice if you click on point, your legs snap. So something is wrong here with our settings. We need to make sure that under the settings for point, right, you maintain offset. Okay, now you try again. Controller constrains IK, right? And then click on point. So now, when you maintain offset, right, it does not shift. So try moving your controller now and check if your leg works. Okay, and let's try to do the orientation. Remember when I rotate my controller, my leg is not tapping. So this is the next thing that we want to do, right? So same idea, okay? Controller, shift, click on the bone, okay, the feet bone. And under orient, we want to make sure, maintain offset, click orient. So now, I can rotate my feet as well. So you should have the movement and the ability to tap your feet. Done. So this is basically it for rigging, actually. Yeah. So that's, I mean, not rigging, but for constraints. How do you create constraints and IK for today's lesson? This is all covered in just this simple leg. So with that, right, let's apply it to our robot now. So can you delete away your simple leg, and let's go ahead and do the same for our robot. So very first thing we want to set up is the IK, the inverse kinematics. So far everything is moving in forward kinematic, meaning parent control child, and so on and so forth, right? So shoulder control elbow, elbow control hand, so on and so forth. So we want to reverse it. We want the children to be in charge. So we want to be able to plant the feet on the ground when it's walking. We want, let's say, inverse kinematics for hands, right? We want our hand to be able to grab stuff. So especially grabbing stuff, right? We don't want to move our shoulder and try and aim at the object. We are actually taking our hand and placing it on like whatever object is on the table. Correct? So if you can control your hand, it is easier for the animator to aim at objects. Versus if you try and aim it using the shoulder, it's very hard. Right? So whatever we do right now, we are trying to create a program that is easy for the animator to do their job. So definitely you can create a very crappy rig, or you can even give this to the animator and they should be able to animate. But to imagine you do a walk cycle like this, okay? So without any controllers or IK, let's say I want it to walk. So if I want it to walk means the hip must go down, right? And then the leg must bend. So I'm going to take the leg. I'm going to try and bend it. This one, I'm going to try and bend it. Oh shit, it's too low, right? The feet is in the ground. So let me create a ground for you guys so you can see. Okay, so this is the ground. And yeah, so it's very hard, alright? So let's say I need to aim it. Okay, maybe I want the feet to be like this. Alright? And then the toes to be up. So you can imagine, right? The animator definitely can make it walk. But they're just gonna waste a lot of time just to do one leg, okay? So with the IK being set up, with controllers being set up to help their job, right, they can do things much faster. So that's what we are here for. So if you guys like rigging, right, you need to remember that as a rigger, you need to understand what the animators want. In other words, you yourself will need to learn some animation and do some like action scenes on your own, so you can understand how a rig is needed to be. You get what I mean? So if you have never used your own products, you will never know how can you improve it. So that's the same idea. So a lot of the people that that we work with, right, or that some of my, because I have friends who are doing animation, and then they were telling me that, oh, you know, the new rigger that came in, he doesn't really seem to understand what we want. Yes, he's good at rigging, but he makes rig that makes our life difficult. Okay, so from this, right, I mean, usually when I hear like complaints from different departments and things like that, so it starts to get me to wonder that the higher up you are in the production, for example, if you're modeling, you're at the start of the production line, right, the more you need to know. Okay, so for modeling, you need to understand texture, rigging, animation, because you need to know how to create models for people down the line. So for riggers, you might think that, oh, I hate animation, and so I don't need to learn it, I just need to know my job. You're going to be quite limited in that sense, okay? And people will keep coming back to you and go, hey, your rig, can you like redo this part? And things like that. Okay, so bear in mind, if you are doing rigging, you need to understand other department stuff. Okay, so let's do our leg right now. So we're going to do an IK so that our animator can walk, right? Can use the feet to walk. So let's go to skeleton, IK handle. And since we use single chain, okay, it's quite easy, alright? So just click on the top and click on the bottom feet, and you get an IK. So make sure you check your work, move it, and see if it works correctly. Right? Next thing that we want to do is to give it a proper name. Otherwise, later on down the line, you have no idea what you are doing. Okay, so this one we're going to call, I would highly recommend to follow your naming convention. So if you put the left first, right, you need to write left leg IK. If yours is leg left, you know, then you need to follow the consistency. Okay, so mine is left first, so left leg underscore IK. Now for every IK that's created, there's also an effector that is being hidden away inside the hierarchy. So shift click on the plus sign so you can see everything, and then look for effector 1. Okay, so this is being hidden. Let's call this left leg effector. Right, so we have the left leg IK, we have the left leg effector. Got it? So do the same for the other leg. I'm going to go to IK handle, click on the hip, click on the foot, and then give it a name. Okay, once you're done, test your right leg as well. Make sure that it is working properly. Okay. And that is actually it for IK. Alright. We're not going to do any IKs for the arm, simply because most of the time in games itself, right, your character is not really picking up stuff, as in it's not like film where you really have to accurately hold onto an object from the table. So a lot of the times your character will be holding a weapon. That's what it usually holds, right? And the weapon, what it does is it swings around. So it's usually a shoulder action, kind of swing and hit people. You don't really aim your weapon at the person's chest in games, okay? You don't really like, okay, there's the chest. Because you don't know where your enemy is standing actually. So it's all about arm swing. So we're not going to do any IK for the hand. Okay, even when in game, right, when you pick up object, you will see the hand just go through the table. That's it. Correct? Right, so, yeah, so it's just basically yeah, so games we can cheat in a sense that we use a lot of FK for the arms. The only thing that we use IK for is the legs because it's walking. That's about it. Okay, and in more advanced rigs, every skeleton actually has two kinds of function. Every skeleton has an IK and an FK. That means the leg itself, right, for more advanced rigs, can actually switch from IK to FK. So there's like multiple bones in one leg. That means you can see like two leg system in the same skeleton. Yeah, one for IK and one for FK. Same thing for the arm. There's one for IK, one for FK. And the animator has the ability to switch. It means they can say, oh, I want to use IK. Now I want to keyframe in FK. So that is the very advanced version. So in our case, we're not going to do the switch. We're just going to stick to one system. So IK on the legs, that's all. Okay, now let's create our controllers. Okay, so this is already part 2 already, very fast. Okay, so under create, we are going to choose circle. Okay, create NURBS primitive, choose circle. The NURBS circle. And in my top view, I want to position the controller. Okay, you can even scale it sideways so it kind of fits the leg a little bit better. And for some more fancy like riggers, right, they like to customize the shapes. So they can even go to control vertex, which is the vertex form of, is the vertex version, okay, of polygon. And then they will kind of like move the points so it looks like a feet. So you're trying to make your controls, right, look very intuitive. That means the moment your animators look at it, they know what it is meant to be. So that is why, right, sometimes they will shape it, or sometimes they will draw it into an arrow or a box or whatever shape. Okay, so if you want, you can create like a shape that roughly fits your feet. Make it slightly bigger so it's easier to select later on. Okay, so I have my controller here. It doesn't have to look super pretty. Just have to fit the size of your feet and a little bit bigger. That's it. Okay, so let's give it a name. I'm going to call this left leg controller CTR. And one thing to note is that it is very unclean, right? There's a lot of values here. So if the animator wants to animate, they have to remember the 5.006 and things like that. So let's clean this out, right, by freezing transform. So let's go to modify and freeze transform. So now your left leg controller should be squeaky clean. Okay, and notice you have some inputs also. So that is the history, right? So let's delete history as well. Modify, edit, delete by type, history. Okay, so you should not have any numbers and you should not have any history. It should be very, very, very clean. Now the next part, which I didn't exactly talk about earlier on, is that we want to also adjust the pivot of our controller. So just now we straight away moved to constraint, right? So if you look at your pivot point, it's right in the middle of your shape, which is actually fine. But if you were to rotate your feet, right, it starts from like the middle, which kind of don't make sense in a, in most scenarios your feet don't bend from the middle. So we want to move our pivot point so that it is attached to your bone. Okay, we want our pivot point to be at the joint here. Okay, so that every time when your animator select the controller, the joint is, the pivot is there, and it makes a lot of sense visually, right? They know that it's controlling that bone as well. Okay, so let's select our controller, and the shortcut key to move pivots is up here. Okay, remember last week we talked about the D key? The D is to move your pivot, right? So it's the same thing. The D is to move your joint, last lesson. So D is to move pivot. Your joints are pivot basically. Okay, so hold down the D key, and we want to hold down the V key to snap to point. So we want to move it and we want to snap it to the joint itself. So D for dog, V for Victoria, okay, DV, and we want to middle mouse. Middle mouse is your scroll wheel, okay? When the middle mouse click on the joint.
I don't have a middle mouse.
If you don't have the middle mouse, then you just move the arrow. Don't move the center because you might end up rotating it. Okay, so just move the arrow one by one until you hit the center. Alright, those of you who have the mouse, I just learned it last week actually, or last week. You just need to middle mouse kind of click around the area, right? It will snap it there straight away. Yeah, middle mouse click around the area, like jerk your mouse a little bit, and then it will snap there. Okay, so now when you try to select a controller, the pivot point is right at the foot joint, and if you try and rotate it, it makes a lot of sense to pivot from there. Okay, so controllers are important to be clean and to rotate around the correct point, because that means that it rotates around the bones, which is what you have already set up last week. Okay, done? Yeah. Once you're done, the next two things are the things that you already know. We're going to constrain, right? We're going to allow the controllers to control the IK and to control the foot. So we want the IK to move, correct? Not rotate, alright? Rotate makes no difference. So I'm going to click on the controller, shift click on the IK, and then constrain what? Point. Very good, because point is position. Okay, give it a test. Every time you do something small, quickly test to make sure that it's working. It's just like programming, alright? You need to check before all your codes pile up and then you don't know what's going on. Okay, next, rotation. So I want to control the rotation of my bone, my foot joint. Okay, so I'm going to click on the controller. Controller constrains joint. That's the sentence that you need to remember. Controller constrains joint. Right, so controller first, then joint, and I'm going to choose orient. And because we use maintain offset, right, it does not, nothing moves, okay? They are just offset. So give it a try again, and it should be working with your model now. So once you're done, save your work as 0 whatever underscore constraint. Let's say that you have constrained wrongly, right? And you want to undo what you did. Okay, and maybe undo cannot do it anymore for you. So how you remove the target? Same thing, controller, then the bone, for example. Okay, and then you go to your constraint. There's something called remove target. So it's the same idea. Controller controls bone. So controller, bone, and then remove target. So now I can rotate but nothing happens. Okay, that's how you unplug it. Alright, so again, you want to make sure that your controller is squeaky clean. Sometimes some of you are having issues because your controller itself has values. So when you orient or you do whatever constraint, right, your constraint shifts your bone or it, something goes crazy. So you must make sure this is clean. You must make sure there's no history. So when you do constraining, there's no weird stuff happening to your model. Okay. Now we need to do the same for the other leg. So instead of creating the circle, try and match the size and all that, we're going to mirror it over. Okay, we're going to duplicate this guy over to the right side, and then we're going to do all the orienting again. So orientation, all the constraints, right, cannot be copied over. So you are only copying the mesh, that's all. So let's duplicate, Command D, and then we're going to group it, Command G. So once we group it, right, our pivot point is in the middle. We are doing the same thing as we did for the robot arms and legs. First lesson, right, we transfer the arms and legs to the other side. So it's the same idea, okay? And inside the scale for group, we're going to put -1. So the group, right, is nothing more than a temporary thing. So you're using it as a temporary pivot point to flip it over. That's all. We need to rename our left leg, right? So we're just going to go to, we're just going to name it manually for now. So right leg, control, and take it out of the group. So Shift P to ungroup. Remember our joints? How do you group and ungroup your joints, right? So quick refresher for last lesson. We created joints like this. So if we want to break a joint, we click Shift P, right? It's going to ungroup it. And if we want to group it back, you click on the parent, click on the child first, then the parent, and then press P for parent. So same idea of ungrouping. You just want to select your right leg control, right, and press Shift P. So a lot of the shortcuts, they are actually the same idea. They are grouping and ungrouping. They are moving of pivot points. So it's not much of a difference. Remember to clean your stuff. So freeze. There's no history to delete, so don't need. Check your pivot point. Since we mirror it, right, it should be at the other feet as well. So all you need to do is just constrain. So honestly, it's the same deal over and over and over again. So at the end of the day, you just want to know what is it that you want the controller to do. Which bone does it control? And what exactly does it control? Movement, rotation, or both? That's it. Okay, so you should have 2 legs ready to go. You can move. You can rotate. Alright. Next, what we are going to do is arms. So we're going to make sure that our arms is working nicely. And our arms are FK, right? That means forward in a kinematic. So it's very, very simple. It's just orient constraint all the way. Okay, so I'm going to create a circle. I'm going to rotate it by 90 degrees. We're doing the hands. 90 degrees. And in the front view, I want to make sure that it snaps to the center of the bone. So V key. V to snap. Alright, so hold down your V key. And and move your entire object, not just the pivot, but the entire object. Move it to the shoulder. Make sure it's big enough so you can select easily. Duplicate. Hold down the V key again and snap it to the elbow. We won't rotate the elbow just yet, so just leave it as 90 degrees. Just keep snapping. Okay, do the same for all the fingers. So you might want to make some of the controllers smaller so it's not so obstructive. So keep all the controllers straight for now. So just snap it in position. Okay, so this is what you should have at the end of the day. Every joint that you want to bend, right, you need to create a controller for the animator to use. So a shoulder, elbow, hand, and each of your fingers and their joints. And then you want to name them. So you want to name them similar to the name that you name the joints. So I call this left shoulder. So you want to follow the same naming convention as your joints itself. So for finger is, you need to check how you name it, okay? So I think it's something like this. So you can always copy and paste the names and then just change a little bit. Alright, so your naming might differ from mine depending on how you name your bones during class. So just follow according to your bones so you can kind of remember and it's easy to see. Okay, don't do your orient constraint yet. Instead, right, make sure that it's squeaky clean. So I'm just going to select all my left arm area. You can always hide your mesh and your joints, right? And then you can freely select all the controllers. Okay. So freeze transform, delete history. If you were to rotate first, okay, according to the rotation of the bone, and then you freeze transform. You notice that your controller has reset to original position, and it's very crazy for the animator to try to rotate your limbs properly. Alright, so you want to leave the final transformation till after you freeze the transform. So you want to keep it as straight, freeze out everything first, then as a final thing, you rotate it. This is how you do limbs that are slightly bent. If it's fully T-pose, means if your model is completely straight, right, you will not have this problem. You just go ahead and freeze transform. Okay, but for limbs, especially for the hands, whereby your modeler actually model it a little bit bent, in case you need to do IK for your hand, right, you want it a bit bent. If you don't want IK at all, it's okay to be straight. Okay, so in our case, I make it a bit bent. So that will be your final transformation. So same thing for the thumb. After you freeze transform, now you are free to orient it so that it matches your bone. And because of that, you also have a very nice manipulator following your object, because you didn't freeze transform for this portion. So your final transform, your final rotation, right, you want to have the number there so that you have the very nice orientation. Of course, if the animator were to zero it out, it's going to be completely straight. Okay, so that is one of the drawbacks. But then it's still better to have this number there. Okay, so as a final step, make sure you rotate your controllers after you freeze transform. And now you should know what you need to do, right? Okay, so you want to orient, constrain all your hands, because you don't want your bones to stretch, right? You don't want to move your joints like that. I mean, you have like bones that are gonna detach from your model itself. Okay, so we don't want things like that. So all we need to do is just control rotation. Okay, so orient every single one of them. If you want to quickly repeat what you last did, right, you just press the G key. So G is to repeat whatever that you have last performed. So I'm just gonna orient every single one of them. Okay, controller, bone, constraint. Controller, bone, G. Controller, bone, G. G is to repeat. And you can check your model. Ooh, I've deleted my skin by accident. Okay, so once you have done orienting the joints, meaning that your joints now is being controlled by the controller, right? So you can just ignore my mesh. My mesh somehow, I think I deleted history for the mesh by accident. So, okay, but you can see my bones are being controlled. So, while you are rotating the controllers, you can ignore the rest that's being left behind. See, okay, so when I rotate my shoulder, right, you can see that the rest of my controllers are left behind. But it's normal because we haven't grouped them yet, okay, so they are all moving individually. As long as each controller is controlling the correct bone, then you know that you have done the correct job. Okay, so next one that we're going to do is, I'm just going to show you how to quickly duplicate over to the other side again. Okay, so select all your controllers for your arms, duplicate, Command D. Okay, while it is selected, Command G to group, and then -1 scale. So you get the other side. And before you do anything again, you want to change the name first, right? Because you need to have the right name in order to see the connection properly. If not, you'll see all the wrong names inside your inputs, and then you don't know what's going on. Okay, so how do you quickly change the word left to right? you can slowly rename every single one of them, or you can go up to modify, and there's something called search and replace name. So just click on search and replace name, and you can search for the word left, replace with right, and press apply. Oh, maybe I should choose hierarchy. Okay, press apply, and everything will be changed accordingly. Okay, so if you don't remember this small tip, you can always rename manually. I mean, it's no big deal. Alright, so just go to modify and replace and search names. And search and replace name. After that, you can ungroup everybody. Okay, you can ungroup everybody. You can delete history, freeze transforms, and then you can continue doing your orient again. Alright, so that is how you bring your constraints over to the other side. So we have done our arms. Our arms are mainly FK and orient constraint, correct? And our legs are IK. So IK doesn't just involve rotation, it involves position as well, right? Because the IK is done through movement, okay? It's not done through rotation. So IK, you have to control by moving it. So we need to constrain the point. So the last part that we are left with is generally the spine. One thing to remember is that because we are doing robots, right? Robots don't stretch. Okay, if you are dealing with characters, for example, like monsters or organic human beings or cute characters, right? You want to have some squash and stretch, and that's the time when you can move your joints. For example, your IK, right? You can actually move the bones and you get stretchy arms that can go on forever. Those are like cartoony kind of characters, okay, which we won't talk about in this class. So since it's a robot, it's only gonna rotate. There's no like stretching. So we don't have to worry about point constraint at all. Okay, so what we're gonna do next here, gonna create a circle again. And same thing, I'm going to snap it to my very first spine. Okay, you want to scale it so that it's easy to select. And you want one more for the root. And this root here is going to be the center of gravity. Alright, meaning that it's going to move your upper body most of the time. It's going to be the main control for everything from spine to arms. So it's your upper body control. Okay, so you might want to start visualizing how do you want your robot to move. So for the spine, right, I just want my robot to rotate sideways, and I also want him to rotate up and down. Okay, I'm getting a bit distracted because he's not skin. So let's open my already completed file. Alright, so you want your robot to move sideways, right? And in some cases, some of you, your robot might even move up and down. Alright, so it's mainly orient constraint. And the center of gravity, obviously, you want him to rotate as well because it controls the entire upper part of the body. And special, okay, it should be able to move. Because root, right? The root of the whole, the root of your joints is basically the ultimate parent. Okay, it's the parent of everybody. So it should be able to move as well. Right? So that's what we are going to do. Okay, so the first thing I'm going to do is to select my spine. Select my spine control, and then shift click on the spine, and then you want to click on orient. Alright, so this part is orient control. And then for the center of gravity, so you can call it COG control CTR, or you can call it root control or whatever. Okay, so there are actually many different names that people give that part of the body. Some call it the root, some call it the pelvis, some call it the COG. So this is center of gravity. It controls everybody, so except for the legs. So I'm going to parent constraint. So click on the COG controller, click on your root, and you want to choose parent. Make sure maintain offset is also turned on. Okay, and then you parent. So spine is orient, root is parent. So because it's parent, right, you can move it and you can also rotate it. Okay, the last thing that we want to do is to create a global controller that you can move your rig, you can rotate the whole thing, and you can scale him. Basically, you can place him in your scene. Okay, and this is more for animation actually. If it's for games, right, you don't really need to do this. Okay, but let's just learn this anyway because it's one of the more important aspects to be versatile. So if you're doing for anything that you need to set dress, right, put everything together, then global control is important. Okay, so let's create a circle here and let's call this global control. So make sure you freeze transform, delete history. Okay, so what we're gonna do is to connect all the parts together, right? Where's my join? Okay, so at this point in time, if you were to rotate your shoulder, all your controllers are left behind. Right? But your bones are working though, it's being constrained nicely. That's why you can see that it is trying to follow the parents. So what we need to do is to parent them just like how we parent our joint system. Yes, it's exactly the same. So we're gonna put everything back together. So the end of the finger is gonna be parented to the middle, right? So click your end, then the middle, press P. Click the middle to the start, press P. Okay, so the parent should be the last thing you select. So end of the finger to the middle, P, middle, start, P. Okay, end to middle, P. That's it. So for all the fingers, right, of course you can parent them one by one to the hand, or you can actually select all three of them, okay, and then select your hand last and press P. Also can. So you can select all the children and then press the parent last. Yeah, parents the last one, right? So you can imagine all the kids run back to the parents when the parents say, okay, let's go home. So that's the idea, alright? So okay, so start parenting everybody back all the way to the shoulder. Okay, select both shoulders, left, right. Select your spine last and press P. So that your spine is going to control the whole upper body, right? Okay, next is the center of gravity, COG. Okay, that's I think that's how you name it, right? COG. Alright, so this COG is gonna control the whole upper part also, right? So your spine is parented to COG. So basically your COG controls everybody, alright? Followed by your spine, followed by your two shoulders, and then it goes down. Okay, so last one is to make sure that our global is controlling everybody, correct? So I'm just gonna pluck out everything again. Alright, so we have our upper body done. We have our individual left and right legs, which we are not going to connect them together to the hip, because it doesn't make sense if we try to rotate the upper body and then the leg itself is moving, right? So we want to keep the legs planted, and then we want the upper body to be independent. So what we're going to do is we're going to group everything to the global. So the global is going to be the one that moves everybody together. So select your root or your center of gravity. Okay, and select your global and press P. So now your global controls the upper body. Select your left right leg and parent it to the global as well. So now the global controls the leg as well. Right? So you should have your global controlling the upper body, the COG, as well as the left and the right legs. Okay, so COG, left and right legs. So let's try to move our model. It's working, right? Everybody is moving together. Okay, remember to turn on your joints so that you can see that your joints is moving as well. Alright, so everybody is moving. Try to rotate. Okay, actually rotation, I see some errors. The legs are bending in a funny way, correct? So I believe that has to do with the IK not being rotated. So what we need to do is we need to take the two IKs, the left and the right leg IK, and middle mouse drag it into the control. So that's another way of parenting. Okay, is to select the IK here, middle mouse click and drag into the global control. So that's also like pressing P. It's the same idea. So now when you rotate, still weird, you might want to move your bones as well. Okay, and now it's working a bit better. It's not perfect, but at least it's not doing weird stuff. Okay, let's try to scale it. If you scale, you'll notice that because we have put our bones inside, right? Everything is scaling properly. If we didn't put our bones, you try and scale, right? You'll notice that your bones are small. Correct? And your IK is stuck to the bottom. So the moment you parent the bones and the IK, okay, the moment you parent all of them inside, now when you try and scale, everything works well together. Yeah, alright, so at the end of the day, what you need to have is a global control that controls everything. Your upper body, center of gravity, your left right leg controls, your IK handle, your bone, okay, your center root, and all its bones are all inside. Alright, and that's it, that's about it. Okay, so once you have this global control, you can actually start to you can create a layer for it and just put all your layers inside. So what I did was I selected my global control, right, with all the stuff inside, and I just create a new layer called a controller layer, and I added a color, like let's say yellow or blue or green. Alright, so just an obvious color that the animator can see, and you can see your controls now have that color. So it's best not to choose purple, right? Because purple means that it's being controlled by something. So usually we choose like something like yellow, so it's bright enough. So with that, you can hide your bones, you can hide your IK, and only show your mesh and your controllers, and you are good to go.